So I might as well make this video, guys. Let's start by looking at question 1. It says, how many solutions exist to the equation x plus y equals 2? And the correct answer is, there is an infinite amount of answers. There are infinite solutions. All right, so why do we graph? Why do we graph? We graph to represent the infinite amount of answers, right? You put arrows on your line because it continues forever. Function form means get y by itself, so let's write that down. So function form means get y by itself, solve for y. Number 4 says name 3 x values you would choose to graph the line of y equals 1/3 x minus 5. So what 3 x values would you choose to graph this guy? What 3 inputs would you use? 0 for sure. What else? 3 for sure. And what else? And -3, right? Or you could say 6, right? So 0, 3, and -3 are great. Once again, I want to remind you, whenever you have a fraction in front of your x, use that denominator. 0 always works, but you don't want to use 0, 1, and 2 all the time, especially when you have a fraction in front. When you do have a fraction, use 0, the denominator, and maybe negative denominator, or maybe twice the denominator. Now, this next one's an interesting question. It says, find the range of this function for the given domain. So if we understand the vocabulary that we learned last week and that we've been using lately, what are they telling us to do here? They're telling us to find the range. What is the range? Y values. So they're telling us to find the y values to this equation for the given domain. What's domain? X. So what this is really saying is use these x values right here. These guys are x values. They want you to use those x values, and x values are really inputs, and they want you to plug them in. Take this 6, plug it in right here, and then work it out, and that'll give you your first range value, your first y value. So when they say find the range of this given these domains, you're going to plug in each one of those and work them out, and you'll get your outputs, your answers. So let me plug in 6. Let me show you. Zooming in a bit, let me rewrite my equation 1/3 x minus 5, but instead of x, let me put a parenthesis. And of course, in the parenthesis, I'm going to be plugging in my first domain value, my first input of 6 right in here. So I'm going to put 6 right in there. And now let's simplify this. 6 on top over 3 on the bottom. 6 divided by 3 is 2. And 1 times 2 is 2. So you're really going to have 2 minus 5, and 2 minus 5 is -3. So for your input of 6, we get the output of -3. So if I start writing my answer right here, let's put the R for range, because that's the notation they use. And the first R value will be -3. That's your first range value. Your second one is going to be to plug in 9 right in here. And if you go 9 here over 3, that's like 9 divided by 3. What's 9 divided by 3? 3. And what's 3 minus 5? 4. What? 3 minus 5? -2. -2. So the next one is going to be a -2. I didn't show my work there. Let me show my work on this last one. Let me rewrite 1/3 x minus 5. And let me plug in my third and final domain value, my third and final input, my third and final x value right in here, which is a 12. So if I plug a 12 right in there, I have 12 on top divided by 3 on the bottom. That becomes 4. And 4 times 1, why do I say 4 times 1? Because there's a 1 up here. 4 times 1 is 4. So you have 4 minus 5. What's 4 minus 5? -1. So the final output is -1. The final range value is -1. So for this particular question, for this equation, if I use the domain 6, 9, and 12, we have a corresponding range value of -3, -2, -1. I hope you guys understand that. Let's move on to the actual graphing part of this thing. Number 6, is it in function form? Yes. So we could jump straight to our input-output table, and we could use 3 easy values like what? 0, 1, and 2. Thank you. And let's plug in 0. Negative 2 times 0 is 0, and 0 minus 1 is negative 1. When I plug in 1 right here, let me actually show my work on this one. I want to have negative 2 times x minus 1, but I'm really plugging in the 1 inside of the parenthesis. So I have negative 2 times 1, that's negative 2. Bring down the minus 1. Negative 2 minus 1 is negative 3. So when I plug in a 1, I get out a negative 3. Now, so far, I have 2 coordinates, 2 answers, 2 points on this line. I want the third one just for fun, right? You only need 2 to draw your line. So if I go to the coordinate 0, negative 1, here it is. If I go to the coordinate 1, negative 3, here it is. I already know that my line is this right here. But I'm going to use the third one just to verify, to feel more confident in the line that I just graphed. So let me plug in 2 into the function. So let me do this. Down here, negative 2 times x minus 1, and I'm plugging in a 2 right there. So negative 2 times 2 is negative 4 minus 1. It gives me a negative 5. So if I go to 2, negative 5, 2 on the x, negative 5 on the y, I'll see that it really does land perfectly on that line. So 2, negative 5 is the coordinate down here, and it really does land perfectly on that line. Put arrows at the end of it, and we have the graphed line. Let's try number 7. Number 7, is it in function form? Absolutely not. So what do I need to do? We're going to first start getting the y by itself by getting rid of minus 6 by adding 6. So let's do that. Let's go plus 6 here and plus 6 over here. So negative 6 plus 6 is 0. Let me rewrite what I have so far. I have 2y equals negative 3 plus 6. Actually, negative 3x plus 6. Now, I still need to get rid of the 2 that's in front of the y. So what do? Divide by 2 and divide everything by 2. Divide each item by 2 or each term by 2. So on the left side, I now truly have y by itself. Let me write it in red over here. Y is by itself. Y equals. And notice right here, negative 3 over 2, I can't do it. I'm just going to leave it like a fraction, negative 3 over 2. Of course, it has an x on it. And the last term, 6 divided by 2, you could actually do that. 6 divided by 2 is 3. So now I have it in function form. Now it's ready for an input-output table. Let me ask you this. On my input-output table, am I going to plug in 0, 1, and 2? No, I'm going to plug in 0, 2, and negative 2, or 4. 4 works in this case because the x value on this xy plane, it really does go to 4. So you're cool, you could plug in 4, or you could use negative 2, whatever you like. Now, plugging in 0 is the easiest because when you plug in 0, it cancels out. Negative 3 halves times 0 is 0, and 0 plus 3 is 3. So we get a 3 right here, and that's a coordinate 0, 3. If I go to the coordinate 0, 3 and put a dot right there, I have 1 point so far. Let me go to the next one, 2, and let's find out what our y value is. So in order to do that, I'm going to rewrite my equation, negative 3 halves times x plus 3. But I'm going to plug in the 2 where the x was at in parentheses. And as you can see, the 2's cancel, and we have negative 3 plus 3, which is 0. Negative 3 plus 3 is 0. So if we go to the coordinate 2, 0, and put a dot right there, 2, 0, it's right here on the x-axis, I already have enough information to graph my line. It would simply be this line right here. We're going to find a third point just for fun. Let's plug in 4. Now, if you plug in 4, you already know your answer is going to be somewhere down here. We're probably going to get the answer negative 4. That way it lines up perfectly. You'll see that the answer really is negative 4. Check it out. When I plug it in, I'm going to have negative 3 halves times x plus 3. And we said we're plugging in 4. So the 4 divided by 2 is really 2. So I really have negative 3 times 2, which is negative 6. And negative 6 plus 3 is negative 3. I think I got that wrong. Let's check it out. Let's see if it lines up. So Negative 3 was our output. Let's go to the coordinate 4, negative 3. That way we could verify if we got it right or wrong. 1, 2, 3, 4. 1, 2, 3. Actually, yeah, that does look perfectly lined. So let me put a dot right there. So positive 4, negative 3 is right here. And as you can see, it really does line up. Put an arrow at the end of each part of the line, and you're good to go. Okay, let's jump to which one? Pick one. Number 11. Number 11, there's a typo smudge right there. Sorry about that. What this is saying is y equals negative half. So let's go to an XY table. The only thing that this equation cares about is that your y values are negative half. So let me do this. On the y side, I'm going to put negative half. On the x side, since there are no x's in this entire equation, it doesn't matter what you plug in for x. So you could plug in 0, 1, and 2, or you could plug in 0, negative 2, and positive 3, whatever you want. Now these guys are coordinates. So let's go to the coordinate 0 and then negative half. 0 on the x, negative halfway down on the y, it would be this dot right here. So let me put a dot halfway down. There it is. That's the coordinate 0, negative half. Let's go to the coordinate negative 2, negative half. So if you go negative 2 on the x and then halfway down, you'd have this point right here. So let me put that point right there. Negative 2, negative half. And also positive 3, negative half. It's going to go positive 3 on the x, negative half on the y. Now if you look at those three red dots, it really does produce a horizontal line, completely flat, running left to right through the y value of negative half. We should have remembered that from yesterday. Whenever you have a y equals a number, it's a horizontal line. Whenever you have x equals a number, it's a vertical line. So for example, on number 13, we have x equals 4. You don't have to do the xy table, but if it helps you understand it better, go for it. The only thing that this equation cares about is that your x values are 4. And your y values, since there's no y in the whole equation, who cares about y? You could plug in any numbers you want for y. So you could do 0, 1, and 2, 0, negative 1, positive 3, whatever you want. Now if you look at these coordinates, 4, 0, 4 on the x, 0 on the y, it is right here, 4, 0. If I go to 4, negative 1, 4 on the x, negative 1 on the y, it's down there. If you go 4 on the x, 3 on the y, it's up there. As you could see, this is a vertical line, which we had this in our notes yesterday. If you have x equals a number, like right here, x equals 4, go to your x-axis, go to the value of 4, draw a vertical line through it. Now if it's y equals a number, like check out number 12, y equals negative 2, you go to the y-axis, here's the y-axis, go to the y value of negative 2, which is right here, and you're going to draw a horizontal line through it. So you go to the y-axis, you go to negative 2, and you draw a horizontal line right through it. And you graphed it without even doing an XY table. I mean, to understand it better, it's a good idea to do the XY table, plug in negative 2, negative 2, negative 2 for y, because that's the only thing that this cares about. You can plug in any numbers you want, negative 3, 0, 1. You can plug in any numbers you want for x, because there is no x. And you will get this exact horizontal line crossing the y-axis at negative 2. For funsies, should we do number 9? Why not? No, not enough time. Okay, then we'll stop right there. You are responsible for having all this complete.